Mass timber is emerging as a revolutionary material in the construction industry, offering numerous benefits in terms of structural integrity and seismic performance. In this video, we'll be delving into some of the key advantages of mass timber construction, particularly focusing on its high strength-to-weight ratio, compliance with modern building codes and standards, seismic design capabilities, lightweight properties, and energy dissipation characteristics. High strength-to-weight ratio. Mass timber constructions are renowned for their high strength-to-weight ratio, which surpasses that of traditional building materials in many areas. Compared to steel or concrete, mass timber offers incredible structural capabilities, whilst being significantly lighter. For instance, radiated pine, a type of wood commonly used for mass timber, has a strength-to-weight ratio of about 20% higher than steel and up to 5 times higher than unreinforced concrete under compression. This outstanding characteristic enables mass timber structures to deliver exceptional performance with reduced material weight. Advanced engineered wood products, such as cross-laminated timber, glue-laminated timber, and laminated veneer lumber, further capitalize on wood's high strength-to-weight ratio. Cross-laminated timber panels provide strength comparable to concrete, but at a fraction of its weight. Glue-laminated timber beams offer robust and versatile solutions to various construction needs. And laminated veneer lumber exhibits strength similar to hot-rolled steel sections, yet retains the lightweight nature of timber. These impressive strength-to-weight benefits, coupled with the renewable nature of wood, make mass timber a compelling choice for contemporary construction. The potential to design strong, lightweight structures expands the possibilities for architecture and engineering, particularly in mid-rise and tall wood buildings. Codes and standards. Modern building codes have evolved to accommodate the use of mass timber in various types of construction, including tall buildings. The 2021 International Building Code, for instance, introduced new classifications for fire-resistant mass timber structures, allowing for structures up to 18 stories high. These changes reflect the growing recognition of mass timber's structural capabilities and its potential to meet safety and performance standards. Seismic designs. One of the critical aspects of seismic design in mass timber buildings is the use of strong and flexible seismic joints and connections. These connections are designed to absorb and dissipate seismic energy, thereby reducing the risk of structural failure. Advanced connection systems, such as tectonous seismic dampers, provide both energy dissipation and self-centering capabilities, ensuring that the building can withstand and recover from seismic events. Lightweight. Mass timber buildings like T3 weigh about 1/5 as much as their concrete counterparts, leading to a significant reduction in seismic mass. This lighter weight decreases the inertial forces generated during earthquakes, improving the building's seismic resilience. The lightweight nature of mass timber also results in considerably lower foundation loads, allowing for smaller and more cost-effective foundations. This efficiency doesn't compromise structural integrity, but rather enhances sustainability and the practicality of building designs. Energy dissipation. Mass timber structures often incorporate redundant load paths, which provide multiple routes for energy dissipation during seismic events. This redundancy ensures that even if one path fails, others can continue to carry the load, thereby enhancing the building's overall resilience. Ductility is another crucial factor in the seismic performance of mass timber buildings. Ductile materials can undergo significant deformation without failing, which is essential for absorbing and dissipating seismic energy. Mass timber, particularly when used in conjunction with advanced connection systems like the tectonous seismic dampers which we mentioned before, offers a level of elasticity and flexibility which enhances its seismic performance. Conclusion: mass timber is proving to be a highly effective material for modern construction, particularly in areas which are prone to seismic activity. The combination of all of the benefits that we mentioned in this video make it an ideal choice for modern construction applications. If you haven't already downloaded the mind map that includes all of the benefits of mass timber, head over to our Patreon page. There you can see and download the mind map for free.
Stay informed, stay inspired. TimberTalk.